All right, hey there, guys. I'm gonna get right into. Hey, how do you like the bottom of my face? Hey, I'm gonna get right into what we're gonna be doing for today. We're gonna do this activity, and then you've got a couple questions I want you to do from the textbook for me. So, pay attention, take notes, and I'll give you credit for what you've done. So, here we go. If we take a look at the problem that we're given right now, it says line of best fit. Now, I'm pretty sure that you guys have studied this already in your science class, and so I'm going to go over some things that will be probably a review, but will also be maybe an introduction or for some of you. So it says here, the following table shows the weekly rainfall, X centimeters, and the number of tourists, Y, by the thousands, visiting a certain beauty spot for 9 successive weeks, okay? Now, I do want to apologize how incredibly granular this printout is. I tried to stretch it so you could have a better graph, and it just didn't work out the way that I wanted to. So I apologize about that. So what I'm going to do right now is I'm going to pause the video, and I'm going to quickly plot these points. And when I come back, you want to have these points plotted as well. So take a moment and go ahead and plot the points for me. All right, and so we're back. Hopefully you're able to plot those points there. The next thing we're going to do, we're going to kind of answer some questions here about these points. So the first thing says, what's the mean rainfall? Now mean, remember, means average. So what I'm going to do is I'm going to add up all of my rainfall. So the entire amount of rainfall over the course of this 9-week period is 64.7 inches. Now, if I want to find the average rainfall per week, I'm going to divide by 9. And so I get, did I do that right? Oh, you know what? This is why I got it wrong. Not 45 there for that first one. It should be 4.5. So let's try that. There we go. Divide that by 9. That looks better, okay? So your average rainfall per week, again, we're going to add all the rainfall divided by the number of weeks, is going to be 2.7 centimeters, okay? Now the mean tourists, okay, not the mean tourists, but the mean tourists, right? The average number of tourists that came in, if I add those up, 5,000, 8,000, 0.8, so 800, 4,200, 4,800, 7.4, so 7,400, 9,400, 8,600, and 2,600, okay? So over the 9-week span, there were 50,800 tourists that came through this, this beauty area. So if I divide that by 9 per week, we're looking at about 5,644, 5.644, which would mean 5,644 tourists per week. Okay. Now, we're going to plot the average X and average Y, and we're going to draw parallel lines to the X-axis and Y-axis through the point. So if you look down here, this is what it says. Plot the average X and average Y. So average X would be 2.7. Okay, so I'll just make a approximation right there. 2.7 is probably right about right there. Okay, and the average tourist, 5.644, we're probably somewhere right in right there. So if I plot that point, we're looking at something right in about there. Okay. And then it says draw lines parallel to the x-axis and y-axis through this point. This splits the scatter plots, so this is what's called a scatter plot, plotting points that are scattered throughout the graph, into 4 quadrants. In which quadrants do you find the most points? Okay. So as I go ahead and draw this, a line that's parallel to all the y-axis would be this one. And a line that is parallel to the x-axis would be something like this one. Okay. Now, as I look at this, most of the points, we have 3 up here in this quadrant. and we have 5 down here in this quadrant. So if you remember, the quadrants are labeled 1, 2, 3, and 4. Okay? So my answer for number 5 is that, let's see here, in which quadrants do you find the most points? I'm going to say in quadrants 2 and 4. Okay, that's where we find the most points there. Okay? Now the next part says this: draw a line of best fit, draw an oval around the data. The line must go through the average x and average y, and the line of best fit should go through 2 quadrants that contain the most data. So again, if I want to go ahead and do this, I'm going to probably just draw something like that. And then a line of best fit, it's got to go through this point right here, okay? And so I can hinge it and I can move, I don't know. In our lines of best fit aren't going to be the most accurate. We're going to do them as best we can. Maybe somewhere right in there. I'm trying to estimate a line that would be, representative of all those points, okay? Excuse me. Now, number 7 says this: on the 10th week, there were 4 centimeters of rainfall. Use your line of best fit to estimate the number of tourists that had visited the beauty spot on the 10th week, in the 10th week. So if I go here, 4 inches of rainfall, right? If I go up here at the line of best fit, let me do that better here. 4 inches of rainfall. If I go up here, line of best fit, we're looking at 3 point something. So I'm going to say like 3.7. 3.7. So I'm going to say 3.7, which translates to 3,700 tourists. Okay, that would be my best estimate based on our graph. By picking appropriate points, find the slope of the line of best fit. Okay. Well, I already know what this one, what I estimated it to be. I said it was 3.7, right? And this point right here, we already knew was 2.7, 5.6. I'll say 5.6, not 5.644, okay? So I'm going to use those 2 points, 3.7, and 2.7, 5.6. Okay, now remember, if I take the difference in the y's, so if I take the difference, 5.6 minus 3.7, over the difference in the x's, 2.7 minus 4, okay, this is a little less than 2, so 1.9, and this is going to be a negative 1.3, okay? Now, I know I don't normally tell you to leave those as both whole numbers, but I'm actually going to calculate that out. 1.9 divided by 1.3 is negative. It'll be a negative because one's positive, one's negative. 1.9 divided by 1.3. There we go. A negative 1.46. Okay. All right. So again, negative 1.46. That's our slope. Okay. Interpret the slope in context of rainfall and number of tourists. Now, if you think about this graph, okay, this is the amount of rainfall, this is the number of tourists. The more rainfall I have, the fewer tourists come to this place, okay? So again, rainfall down here, tourists up here, okay? So the more rainfall I have, the fewer the tourists, okay? So I'm going to say something like that. The more rainfall, the fewer the number of tourists at the beauty spot. Okay. Now, the next one says this: find the equation of the line of best fit and use it to check your answer in part 7. Okay. So if I do this, let's see here. My slope was, what I say, negative 1.46. So y, let's see here, and I use 4 on 3.7. So y minus the y value is equal to the slope x minus the x value. Okay? So if I work this out, negative 1.46x, negative times negative is a positive, and so 4 times 1.46 ends up being 5.84. And then if you add 3.7 to both sides, .84 plus 3.7, 9.54. Okay, so that's my equation. Okay, now yours can be different because, again, maybe your slope was different. Maybe how you graphed it. And again, line of best fit is the best estimation, and there's room for error for that. Now, to check my answer, to make sure that this is correct, remember we're going to plug in 4 centimeters for the x. So if I do this, y equals negative 1.46 times 4. And if I plug that into my calculator, negative 1.46 times 4 plus 9.54, 3.7, 3.7, okay? So we just validated we should have the same outcome there if it was on that line, okay? So, yeah, again, your numbers can be a little bit different. The last part says this: the manager of the cafe at the beauty spot has to plan, not sure what that says there, has to plan staffing levels, that's what it says. A mix of a full-time and part-time staff are employed. In light of the information above and the fact that the correlation coefficient is negative 0.78, what advice would you give the manager? Okay. Now remember what we talked about. This is a fairly strong correlation. Okay. Negative 0.78 is closer to 1 than it's not. So as a result, I'm going to say if rain amounts are predicted at a higher level for the week, at a higher level for the week, comma, less staffing will be required. At the beauty spot. Okay, so hopefully that makes sense there, folks. You know, I went through that kind of quickly. Again, I can take, if it's on a test or quiz and we're doing this, if you have numbers that are slightly different than mine, as long as you can justify why you use those numbers, I will be okay with that. So with that being said, thank you. Make sure you do the problems from the textbook, and we'll talk to you tomorrow.